This tutorial focuses on how you can analyze a quantitative variable with respect to a categorical variable. At the end of this video, you should be able to visualize a quantitative variable with respect to a categorical variable using the ggplot2 package, and you should also be able to aggregate data across categories or apply functions across categories. In the second part of the lab, we'll look at how a continuous quantitative variable varies across different categories. In this case, we'll be treating the regions that the cities are in as the categories. So one of the first things we should do is check what regions are in our data set. And to do that, we can use the unique command. So our column for regions is called region. And so I'm going to run this just to check what we have. So you can see down here, these are the regions that are included in the data set. In categories are referred to in R as factors, and they have different levels. So these are the levels that are available in our data set. And so we will create a plot that has a box plot for each region. So again, I'll set up my ggplot with this first line. We have our data assigned, but this time with mapping, you can see I have an x and a y variable. My x variable is the region, and then my y variable is the emissions. And so we'll go ahead and do a box plot for this. So you can see in our plot, now on the x-axis I have the region, and then I have a box plot for each region. And we talked a little bit about outliers, and in this case you can see within each region we do have some outliers. So if we had outliers with the larger data set, they would have showed up like these points you can see here. So you can see in North America we have 2 upper outliers, in Africa there's 1 lower. So this would be what outliers look like when they do show up. And right now, the default in R is that the categories are organized based on the alphabetical order, based on the first letter. That's not really meaningful in this case, so I'm going to reorder these region values by the emissions, so they'll be in ascending order. So now let me run that again. And now you can see our box plots are reorganized so that they are in ascending order. And then ascending order looks like it's probably based on either the mean or the median. And again, just like last time, I'll add in a title and center it. And as you can see, the x-axis title will be whatever is mapped to x here. So you can see it's this reorder, and that is not a great way professionally to present this, so we're going to rename that x-axis to just be region. So now you can see it just reflects the region. And your action item for this lab is to work on this y-axis label. The y-axis label here doesn't include the units, so I want you to add those units into this plot. Earlier, we calculated descriptive statistics just for greenhouse gas emissions alone for the whole data set, but now we want to split it by region. And as the semester progresses, we'll learn a little bit more about loops in R, but right now I just want to show you the most direct way to do it. It's not the most elegant way, but it's the easiest way when you're first learning. So one of the best tools to aggregate data, especially across categories, is this aggregate. So I'm going to go ahead, again, our first stop for a new command is searching for it. So let's go ahead and check this out, and that will be in stats. So this stats package is in base R. It has most of the commands that you will need for this class. So if we go ahead and look at the method in the arguments, you can see here that we start out with our x. So our x is whatever is being aggregated. In this case, we're aggregating the emissions data. And then your by is what category you're using. So if you look down the arguments, the by is a list of grouping elements that's as long as the variable in the data frame. Because that's from the same data frame, we can do this. And so I've just converted this by to a list. If you don't have it converted, if it's not already a list, you need to convert it to a list in this case. As you can see, this argument will tell you that it needs to be a list. And then this last argument is the function. So the function that I want to use is this summary function that we used earlier. Remember, it came up with the min, the max, the median, the mean, as well as the 25th and 75th percentile values. So I'm going to go ahead and run this and assign it to this summary region. And I'm going to go ahead and type the summary region down here in the console, and you can see that it includes for each group all of the summary values that we completed last time for the entire data set. And then if you look at the string for this summary region, again, the string command tells you what's in here. You can see that it is split between a factor and then a separate data frame, this X data frame. And so I want to organize this summary region into one data frame. Right now it's separated in between these two, so I'm going to use this column bind and create one data frame. So now if I hit string and I look at stat region, which is my new object, you can see I now have this first row of factors and then these separate columns for numbers. So originally when I first did this aggregate function, it wasn't recognizing the full list of columns, it was just recognizing that this X represented another data frame. So that's just an organizational aspect of the code, but it allows you to work on the code a little bit easier. I'm going to go ahead and replace the column name in stat region. You can see if we look at the stat region in the console, before it was this group 1, and now I've changed it to region. And again, the summary code doesn't come up with range, so I'm going to go ahead and calculate the range. I'm going to add in another column, so by assigning it with a $sign. So you know the column's not there now, but by doing this I can create a new column. And then I'm taking the max column and then the min column and subtracting them to come up with the range. So now when I look at my stat region data frame again, you can see I've added this range column. And then the next thing that I want to do is include a count. So I can't see directly from here how many cities are in each region, but that's useful information, especially for something like Southeast Asia. If we go back to our plot, we can tell that it's only one value. So it gives some context to show how many cities are included in each region. And so this ndistinct is a function that comes up with the count for each group, and this function is actually part of the plier package, which you can see I've added in this dippler and plier packages, and they are mainly for organizing and moving data around. So they're really helpful. You'll see in the script that they're located in here, and you can do some more work about them, but they're really great for organizing larger data sets, especially this aggregation. And so this ndistinct is from one of those packages. So I'm going to go ahead and add in this count region, and then I also want to do the standard deviation for regions, so I've used this function sd in an aggregate, and again I'm going to bind what I return from the count region and the standard deviation to my stat region data frame, and then change the column names for that. And so now I'll go ahead and print this, and you can see I now have what I originally included, the first columns that are generated by the summary function, the range which I calculated, the standard deviation, and then the count. So you can see we don't really have a very even split across region. We have 16 cities in North America. The only thing that's close is Latin America and Europe, and then we have some that are really low. As you move forward with your analyses, you would definitely want to account for these differences in the number of observations across the regions.